Dear students, welcome to MSc third semester. Let us start learning more. You have 4 papers in MSc third semester. Today we will begin with second paper, that is remote sensing and GIS. So your second paper is remote sensing and GIS. It has 4 units. The first unit has definition of remote sensing, and then we will learn about what are various platforms that are being used for remote sensing, and we will learn more about air and space based platforms, although we have ground based platforms also. Then unit 2 is types and characteristics of sensors. Various sensors are used for remote sensing. You already know about many of them while you studied photogeology in BSc. So we will study about various other sensors and their characteristics also. Then we'll get to know what monoband is, although we know what panchromatic photographs are. You have already studied in photogeology in your BSc. And then multispectral, hyperspectral remote sensing. These are various types of remote sensing based on the spectrum or the bandwidth that we are using. Then we'll understand the basics of, we'll understand just the basics, okay, not go into too much of details. If you will have questions, then we'll try going into the details also. And then of optical, thermal and microwave remote sensing. So you have been told about all these windows during the study of photogeology. We will study in detail about all this here. And then we'll study about the concept of LiDAR. It's a kind of remote sensing technique. And then characteristics of IRS sensors, Indian Remote Sensing Satellite System. So there are various satellites. This is a very basic thing, everybody knows there are various satellites which are remotely sensing the earth. So there is a special system, the IRS system for India. So which sensors are used by the IRS system? We'll study about the characteristics of these sensors. Then unit 3 will be the structure of digital image. You already have seen stereo pairs. So now you will study the details of digital images. We will understand the processing of digital image, how they are processed, how they are rectified, how they are enhanced, and how they are classified. Already you are very well aware of what enhancement is. Nowadays everybody is using mobile, and they take various kinds of photographs, and then you use various filters, and then try to enhance various images by rectifying some of the colors. You use some filters, and there are various other algorithms due to which you enhance some image. So similarly, there are various techniques that can be used for image processing that way. So we'll study about that also. And then we will also study about the definition and composition of GIS, Geographic Information System. I hope you all have heard about this word. So we'll study about this in detail. So there are various formats in which data is input into Geographic Information System, that is the raster and the vector data. Say for example, if you see a river always goes from a higher elevation to a lower one. It never goes from a lower elevation to a higher one, right? Now river has some amount of water. There is a flux of water there in the river. So that is the amount, that is the magnitude, and then you also have a direction in which it moves. So this may be a vector format, right? The raster one will only have the magnitude. Say for example, we have census data. That is a raster format. We'll study about this in great detail. I'm not going to go into details here only. Then we will also get basic knowledge about data acquisition, how data is acquired for GIS, how it is managed, manipulated, how it is analyzed, and then how it is represented in GIS. So it is a system, like your body is a system of organs. Organs are a system of, your body is a system which constitutes of basic units that are organs, and then organs constitute of basic units that are tissues. So there are various units which combine together and form this system, which is used for geographic information. So we will study about this in great detail in unit 3. Then in unit 4 we will study about the application of remote sensing. And why are we studying remote sensing? Why are we studying GIS? And we will define ourselves only to few of the application. There are various applications of remote sensing in GIS. You must have studied or heard about these applications in defense many a times. So we will be precisely understanding about the application in geomorphological investigations, tectonic investigations, lithological mapping, groundwater exploration, mineral exploration, oil and gas exploration, and geohazard management. Okay, so the books which are being recommended to you are Lily Send and Keffer, R.P. Gupta, S.A. Drury, J.R. Jensen, Demers, and Richards and Chia. In the library, you have these 4 books. Once the library is open, you can get them. And I'll also provide you with the soft copies of Keffer and Gupta and Jensen. I don't have soft copy of Drury right now. And other than this, I'll be providing you various soft copies and handwritten notes also, which will help you in studying. So for today's presentation, there are various references that I have used. So I'll be teaching you from different parts of these references. So let us start with unit 1. Sorry. It has definition of remote sensing and remote sensing platforms, especially the air and the space based. So in the lecture today, we will study about the definition of remote sensing. So what is remote sensing? You must have heard this word remote earlier also. You use a remote to open your TV, right? You're sitting far away from the television and then you use the remote and then you can switch your TV on or off. Now this is known as remote because you are not in directly contact with the television, but you are being able to operate it. And then sensing, you can sense various things, various factors using various sensors of your body, right? Like you can hear sound using your ears, you can smell odor using your nose. So nose is a sensor for you which is sensing odor, right? Now ears are a sensor for you which are sensing sound. So this is what sensing is all about. There are various sensors which sense different things remotely. Okay, if you are listening to some you're hearing some voice of a train which is going away from you, or say you're listening to the voice of an aeroplane, so you are in remote contact with the aeroplane. You're not in direct contact with the aeroplane, still you are understanding that the aeroplane is going far from you or it is coming towards you on the basis of the sound which you're sensing, right? So this is what remote sensing is. So Lillison and Keffer in 2002, they gave a definition that remote sensing is science. While listening to the sound, there are sound waves which interact with the ear. There is a complex system inside your ear that finally produces some sensation through your nerves, which is interpreted by your brain, right? So this is science. Now art is where you have predefined conceptions that an aeroplane sounds like this or a train sounds like this. Maybe there are different sounds for different objects. So your brain has a preconditioning that a particular sound will be for a particular thing. So here comes the art of interpretation, that on the basis of your sensing of a particular factor, you interpret it. So this is said to be the science and art of obtaining what? Information Simple. About any object or area or phenomena through the analysis of data that is acquired by various devices that is not in contact with the object, area or phenomenon under investigation. Okay. You can learn this definition. The definition was given in 2001 by Randall Smith, sorry. So he said remote sensing is the science of obtaining and interpreting information from a distance using sensors that are not in physical contact with the object being observed, as we have already discussed it. So you can learn any of the definitions. If a definition comes in your exam that you have to define what remote sensing is, you can give any of the definitions from here. I hope you all must have understood it. So in this example, we also have seen this in the online class. So what did you see here? There are different colors. There is ice cream. You could sense, you can understand or interpret that it will be cold, obviously. So these are different perceptions based on your conditionings, the conditioning based on the preconceived ideas of the data or the information. So you can perceive the shape, taste, temperature of the object which is in the hands of the person. Obviously, you are interpreting it to be a ice cream now, right? So it depends upon the experience which you have. Similarly, what is done in remote sensing for geological concepts that we will discuss here, okay? So now you're very clear with what remote sensing is. So while we are studying remote sensing, what we do is we deal with the interaction of electromagnetic spectrum with the Earth's surface features. We very well know what electromagnetic spectrum is. Various photons, they move in a sinusoidal wave pattern and they produce electromagnetic energy. So the main source of electromagnetic energy is sun. We have dealt about this in great detail in photogeology and you know very well about the electromagnetic spectrum. So the sun provides us the electromagnetic energy which has two parts. The wave has the two parts, the magnetic part and the electric part, and it moves in a sinusoidal wave format. The radio waves, they have longer frequency. The gamma rays, they have shorter frequency. So they are measured in meter, millimeter, micrometer and nanometer. The wavelength between 0.4 to 0.7 micrometer is known as the visible light. Our eyes are the sensor which are sensitive to this part only, to the visible part. We cannot sense gamma rays using eyes. We cannot sense X-rays using our eyes. So the eyes are sensors. This is the part of the electromagnetic spectrum which is sensed. Now this is sensed on the basis of various interactions that have been made with the Earth's surface. I'll go into that after this slide. Let us first see that all the radios, they work in the radio wave. The signals which you get in your mobile, they are in microwaves. The oven which you're using is in microwave. You can also sometimes interpret heat in the form of infrared rays. You can see using the visible light and so on. So what happens is the electromagnetic energy, it comes from the sun. Some of it is absorbed, some of it is scattered by the aerosols due to various factors or the clouds, and some part gets absorbed by the surface, be it the mountains, the ground, the ponds, or be it the ocean, and some part is scattered. So the energy comes, it interacts and then it scatters, right? So what happens is the incident energy I lambda in fact, lambda stands for the wavelength. So the incident energy is always equal to the sum of absorbed, transmitted and reflected energy. Very simple. So the incident energy will always be the sum of absorbed, reflected and transmitted energy. This is how electromagnetic energy interacts with the Earth's surface. So while studying remote sensing in terms of remote in geology, we will study its interaction with the Earth's surface mainly. And on the basis of that, we will see how it is applied in various factors which we discussed in Unit 4 earlier in the syllabus discussion. So when we are talking about the remote sensing system, there is a complete system which involves the target, the energy source, the transmission path and the sensor. So energy comes from the sun, it interacts and then it is sensed by some sensor, or sometimes the energy can also be produced by the vehicle or the sensor, and this can be sensed in turn. We will study about these active sensing, remote sensing and passive remote sensing. So basically the active remote sensing includes the energy which is coming from the sun. Passive includes the one which has the EME which we produce and then we also sense the interaction with the earth surface. So either it will come to the sensors, here it is sensed, then it is sent to the ground stations and then it is saved. So this is a complete remote sensing system. So while remote sensing the geological features of the earth's surface, we can sense various features in a small part like this. So we can sense them using ground based platforms, air based platforms, or also the satellites, the space based platforms. So in order to sense the various geological features of earth, what we do is, or in order to remotely sense the earth, either we sense it through ground platforms or airborne platforms or spaceborne platforms. Okay, so in the next lecture we will study about all these platforms. Thank you very much. Feel free to ask questions. So in this lecture today, what we studied is, we studied about how electromagnetic energy interacts with the earth. We understood the definition of remote sensing, right? And then we also got an idea of how many types of platforms are. Thank you very much.